everybody. Doing a video tonight on installing Proxmox on Security Onion. What's kind of predicating this is I'm actually giving a talk at ChannelCon, CompTIA ChannelCon here in a couple weeks. It's particularly on threat hunting on a budget. And this is a talk that I was kind of given the topic on. It particularly mentioned, although I think they pulled it out of there now, it particularly mentions using Security Onion for threat hunting. And I thought it was actually a really good way to get back and actually engage in my thought of, providing knowledge and, kind of rising people up and putting them in a position to do their own thing. And then I saw that it was only a 30-minute session. And it occurred to me that, man, you can't get real technical in 30 minutes. So what I figured I'd do is over the next 2 weeks, as I build my slides out and as I put this stuff together, I will go ahead and create a couple of tutorial videos. And then people that attend my talk, if they want more information or they want to actually be able to do this stuff, they can reference these videos and they can kind of follow along on some of the things that I'll be showing as we go through this. So we'll start here. We're going to be covering Security Onion 2 here. Security Onion is a Linux distribution, and the thought of the Linux distribution here is to basically create a threat hunting sim platform that supports going through and doing some basic threat hunting. It's really powerful. It's really kind of complex. I've run it on and off on my home network here for probably a good part of a year now, or I'll log into it a bit every little bit and I'll play with it. My installation was kind of out of date, so I stood up another one and I'm about to stand up a third here for this tutorial. At home, I don't have a big fancy huge home lab here. I have a couple boxes I run Proxmox on, and that's my virtualization engine of choice here at home right now. So I'm going to go through what it takes to actually install this software on Proxmox. There's some gotchas that you kind of run into as we kind of go through and we kind of do this. So we'll get started here. So here is the hardware requirements for Security Onion. They're pretty hefty, and one of the reasons that they're pretty hefty is that on the back end this thing actually runs Elasticsearch, and the Elasticsearch requirements are actually fairly heavy. So a lot of the requirements of the software are actually driven by the fact that it uses Elastic on the back end. We're going to kind of be running a standalone node here, right? So we can see our minimum requirements here are 12 gigs of RAM, 4 CPUs, 200 gigs of storage. I'm probably going to bump that to 16 gigs of RAM. I know from past experience that when I give it 12, it is very cranky and very unhappy. So we'll go ahead and we'll give it 16. To start out, I went ahead and I downloaded the Security Onion ISO from the Security Onion page. You can just Google Security Onion and you'll find the page. There's a download link on Security Onion's solutions page. That download link will take you here. Here you can download an ISO. I've already downloaded an ISO, so I don't have the disadvantage of needing to do so. So I've actually already got it installed into Proxmox. This is not a tutorial on how to use or install Proxmox. I, in particular, am creating this tutorial because of some of the uniqueness of actually implementing port mirroring inside of Proxmox. So we'll move on. We'll kind of go into my Proxmox environment. When I decided I needed to build out a newer Security Onion instance here at home to start to develop this talk, I actually grabbed another machine from the office and brought it home, put it in my lab here, and it's kind of been my little Proxmox Security Onion playground for the past couple of days as I've been going in and out of this stuff. So I'm going to go ahead and I'm going to build this here. So I'm going to go ahead to my PVE box, my Proxmox box here. I'm going to create a VM. I'm going to put it on PVE2, which is the name of this node. The name is, I'm just going to call it SO2. It's my second Security Onion box. For OS, I'm going to tell it that it's on local. The ISO image is the Security Onion ISO. The version of it I'm using is actually a couple days older than what's present when we do this right now. It is a Linux guest OS. For system, I'm going to go ahead and accept all of the defaults here. I found that they work just fine. For disks, I am going to give it a 200 gig disk, and I am going to put it where I have room to put it. So let me figure out, it's gonna have to go NFS. I don't have that much storage on this box I grabbed, so I actually have an NFS data store. It is not recommended to run Elasticsearch over NFS. It works okay for low volume loads. It just happens to be what I have here for this demonstration. I recommend you use a box that actually has enough local storage, relatively fast storage. In production use, it's actually recommended that the Elasticsearch nodes run on fast RAID 1.0 or on SSD. And if you go back over to this requirements page, it talks a little bit more. In production, you'd end up probably running this in a split mode, where you'd have a manager workstation, one or more search nodes, one or more forward nodes at your clients, right? This would be the thing you would run at your client to collect network data, forward it in, and then maybe some receiver nodes that you'd put in your DMZ to receive the data from your clients, then maybe a couple of honeypot nodes. We're not doing any of that stuff here. We're just running for this very simple demonstration here. We're running a standalone node, so our 200 gig NFS will work fine. It's low volume. I'm going to give it 2 sockets, 2 cores to get to my 4 total cores that this thing wants. Go ahead and under memory, I'm going to give it 16 gigs of RAM. All right, so 16,384. And on network, right now, I'm only going to add one network interface, and I'm going to attach it to VMBR0, which is the default VM bridge. We'll add the other one here in a couple minutes because there's some gotchas, again, with the networking to get the mirroring working. So we'll go ahead and we'll confirm. We'll let it do its thing. It'll take a second. Should pop up here in a second. We have it. We're going to open the console and we're going to go ahead and start it. So let's make this bigger. And it doesn't actually get bigger, but it's fine. We'll let it roll. It should get bigger here in a minute once the installer starts. So it's going to go ahead and do its thing for a minute. Should eventually land on a GUI or a GUI based installer. There it goes. It's doing its thing. And cool, we have the installer starting now, so that'll just take a second. We wish to continue. I'll give it an administrator username as just of admin. I'm just going to provide it a temporary password that I use for this stuff. Forgot this actually, Security Onion actually does not. It uses a text-based installer, so the text is probably pretty small here. So it's doing an automated install. It goes pretty quick. It really only asks that one question. We'll let it sit here. I'll probably fast forward this a good amount in the actual video that you guys see because it takes a couple minutes and it's pretty not that exciting. So we'll sit here and we'll let it do its thing. So now that's a little bigger. We're going to log in as that username and password we set earlier. And we get to a getting started screen. We'll go through the setup. We're going to install it. We're going to tell it we want a standalone node. Eval would actually honestly probably be okay here too. I like standalone to play with it. If you're actually going to try to run it for your MSP or yourself, I would recommend at the very least you do standard or standalone. You might be doing distributed depending on how big you want it to be. We have to agree to the Elasticsearch license. Yeah, we'll continue that for now. We use security onion. We'll give it a thing. Tell it our management nick. For this instance, I'm just going to use JCP. That's fine. We'll let it initialize. This will be a mystery for everybody here because I've never actually configured one without a monitor interface. So we'll have to go back and add it. Normally, I add the second nick before we get to this step. But we're going to go ahead and do it now. So it's going to download and install some stuff. So it's doing its pre-flight checks. This is another area where probably fast forward through it for you. It takes a couple minutes to install that. So we'll be back. And we've actually hit a new day with it. So when I come back here, you'll see I'm in a different outfit. Took a little bit longer than expected. Really kind of pounding the NFS share with my other install. So let it go overnight and back at it today. So we'll go ahead and we're gonna let this thing reboot. Then we'll see if it okay, yeah, it was on its way down. I'm just impatient, so might have to FSCK now. Let it go ahead and start booting here. Cool. Gotta log in. Yeah, it's doing stuff. It's gonna probably take a couple minutes for Salt to run and all the other things that it's doing. But while that is happening, let's move our attention over to the other piece of this that we need to handle here, which is the other interface we have to add here. So we're gonna go ahead and let me make this thing or fit this thing to the screen there. There we go, cool. So we're back to our full screen window. In this case, what we're actually gonna do is we're gonna go into a shell on the host. So I'm gonna choose my host here and I'm gonna go ahead and click this shell window. This one, we won't be in here super long, so I probably won't actually grow it. I'll put the commands I'm actually going to run somewhere else. So the first thing, so for us to build a monitor link, we basically have to, first of all, configure a switch or other network device to send data over to this host. In my case here, I actually have Cisco switches and Cisco networking gear that lives at the edge of my network or in the core of my network here in my home lab. So basically what I've done is I've configured what's called a span port over to a switch port. That switch port is then connected to a physical interface on this Proxmox box here. That interface is actually called, we can see it right here, it is ENP66S0F0. This host I'm using here actually has 8 gigabit NICs in it, 4 which are on board, which are these ENO ones, and 4 which are an add-on card, which are these ENP66 ones. Right, so I have the span port from my switch configured and plugged into ENP66S0F0. I'm not going to cover configuring span here. It's a little bit outside of the scope what I was trying to cover here with regards to this, and there's plenty of documentation and other videos available on how to cover span. So we'll take our Proxmox box here, and the first thing we're going to do is configure OpenSwitch. I've actually, over the years of, probably year and a half, I've been using Security Onion. On my other Proxmox host, I've actually configured the port mirroring using a combination of Voodoo Magic, some aging and STP config, setting various interfaces to promiscuous mode, and a bunch of other things that, while they work, they're just, it's super funky, and every time I had to mess with it, it's just a matter of messing around so it works. Fortunately, on the actual Security Onion page here, there is a link in this documentation set here, and there's a Proxmox page right here. The Proxmox page points to a GitHub issue. The GitHub issue says, hey, this is actually really hard to do with promiscuous mode on Proxmox. This links to another article here that talks about how to do port mirroring on a Proxmox, and it uses Open vSwitch. An Open vSwitch is it's a set of Linux packages you install that give you a lot more flexibility of configuring switching on Linux hosts. You can actually turn them into essentially full-fledged switches. You can configure VLANs on them pretty easily, legs or bonds or trunk ports, spanning. A lot of packages like OpenStack actually use this on the back end. What occurs to me. Not actually on the screen, so we'll come back up here. A lot of packages like OpenStack end up using this on the back end, but we're going to use it here. I went ahead and I used the documented thing here of using VMBR4, not for any other reason other than the fact that at some point on this Proxmox box I might actually add a couple more network interfaces, and I wanted essentially the bridge one or the span one to be the last one. So assuming that eventually I might have a host only network and maybe some other network, right, that gave me 2 more to play with. Plus it kind of matched the original config of this box where I had the span port was actually on the 4th port, right? So I was connecting VMBR4 with EN04, right? So I went ahead and I called that VMBR4. To do that, we need to actually install the Open vSwitch package. It's installed on my box here, but I'm going to issue the commands to do it anyways. So it's apt install open vSwitch -switch. It's going to tell me it's already installed on this. And then once that happens here, we're going to run this IP link command. And what we'll see is we see these tap interfaces, right? So we end up with a couple of interfaces per VM that we actually create. One is a firewall if you're actually firewalling on a given host. The other one is a tap interface, right? So we can see tap 101I0, right? That's actually the tap interface that the host ends up connecting to for VM 101, which matches this ID up here, port 0 or interface 0. So now that we've got that created, we can go back to our security onion box. We can go to the summary of it. We can actually go to the hardware of it. We can add another network device. We're actually going to connect that to our VMBR4. And actually, I didn't show you guys how to create that, so I'm going to add it, but then I'm going to go back and I'll show you guys how to create that VMBR4. And I actually created that on the wrong one, so let me go ahead and remove that and create it on the right VM here. Cool. And now it's there. So to create the actual network, what I've done is you go into the actual host, you go to network, you go create an OVS bridge. You give it a name. In my case, it was VMBR4. And then the only other thing you need to put in, you need to make sure auto start is selected. And the only other thing you need to do is name the physical port you want to connect it to. So in my case, it was ENP66S0F0. Right, I created that, and here you can see that actually creates an OVS port type here that's active and has auto start set to yes. We can see the OVM bridge also gets created, or OVS bridge, VMBR4, right? It uses ports of slave ENP66S0F0, set to active, set to auto start. Cool, so that's created. Now on our guest here, we actually attached that guest to that interface. So if we go here, and we run IP link again, we'll see we have this new interface, which is tap 101 I1. So one thing I do want to do on this this network interface card here is I want to go back to it. We'll edit that interface. We're going to turn the firewall off. Don't want the firewall on it. When we do that, and we go back over here, we can see that we actually lose the firewall here, right? So now we only have firewall PR 101 P0. We don't have one on P1. So if we look at this, we can see that the lower is up on it. Everything looks good. Everything seems fine. So now if we go back to our guest here on the console, we should, I think I get ifconfig on this, not IP link. Yeah, you can see we have a bunch of interfaces here. Let me pipe that to less. We have ETH1. That is our new interface we just added here. You can actually see we're receiving a lot of packets on it. We're actually transmitting some packets. And I actually did look up the command we need to run, and it's so-monitor-add, and then we just tell it ETH1. And so we'll run so-monitor-add. We'll add the ETH1 port. And in theory, in just a moment here, this thing will be configured, and we can go ahead and log into it. Cool. So we successfully added that connection there. So now, that one dot, well, what IP did it get? I guess I need to look at that, don't I? 144. We'll accept that. We'll go to it. It has a self-signed cert, so it's broken. That's fine. We'll log in, and we've logged into Security Onion. You can see here that we've got, some dashboards and some stuff we can look at. Nothing's going to be too exciting right now because I don't have that much data, and we haven't really collected anything yet. But I'm going to go ahead and I'm going to stop this here because this is where I wanted to cover. At this point, well, I'll check one last thing. We'll go into Grafana here. Actually, we'll go to Kibana. We'll log in there. And if we go to Grafana or Kibana, we should start to see some connections. And so that's what we're kind of looking at for here. I'm going to go for the last 15 minutes because this is data, recent data I want to look at. So we see some Elastic, we see some DNS entries, and yep, we're starting to see connections, right? So we can start to look at them here. I don't know what kind of interesting network traffic is going on my network right now, but we'll go ahead and we can see, connections connecting to various things. In this case, actually, I'm a little suspect of this because this looks like it's mostly broadcast in multicast traffic. So it looks like it may be the case here that I'm not actually getting proper connectivity and receiving the data properly. So let's go back over to our host. It should be right here. And let's look at ETH1 and see if we are actually seeing data. Nope, and that is all multicast. Look at that. We're seeing some broadcast traffic for an overlay network that I have running there, but generally that is all multicast traffic. So this is not behaving properly. Oh, we haven't run the command yet. That totally makes sense. So we actually added the bridge here that I was trying to add, but we never actually finished configuring it. Duh. So we need to actually run a couple more commands to be happy here. We're going to run OBS via CTL, clear, bridge. Well, I'm actually not going to clear the mirrors because I don't want to disrupt my other one. But the command you would run is OBS via CTL, clear, bridge, VM BR4 mirrors. And then we're going to run OBS via CTL --ID equals at P, which is, we're setting an ID here. And we're going to set that to get port tap 101I1. So we're going to get the port for tap 101I1 --, then we're going to do -ID. We're going to set our mirror port to @M. We're going to create mirror name, and I'm going to call it span 2 because I already have a span 1 in this box. So we're going to select all equals true, so we get all traffic, and we're going to set the output port is equal to @P, so it's going to be here, right? So it's going to go to tap 101 @I, right? And then we're going to do --, and then we're going to do set bridge VM BR4 mirrors equals @M. And that is done. And so if that happens, now when you're on TCP dump over here, we should start seeing all sorts of additional traffic that's happening on my network. And you can see, yep, we're seeing some HTTPS traffic. We're seeing all sorts of interesting things. And if we come back over here and we reload this, we should start to see all sorts of extra interesting destinations that things on my network are talking to. May take a second for that data to filter in. Well, let me go back to the last 15 minutes again. Yep, I'm seeing some traffic to 8888, which is expected. Lots of interesting 192.164 traffic. That's cool. But you can see 192.168.1.4 talking to 45, right? You can actually see some traffic happening now. And that is where I'm actually going to end this video. We'll take it over next time with actually starting to use some of this data that we get in here. I'll probably move back over to my other security onion instance that's been running it for a while, so we have a little more data. We'll throw some interesting stuff at it, and we'll go from there. So thanks for watching.